I mean, one of the things that was a thread through my research was how often the big impacts of technology and science in everyday life had to do with communication between people, basically. And this I have a chapter on education, and it leapt out very strongly in the chapter on education that one of the almost across all disciplines, whatever teachers were finding to do interesting with technology, generally always came down to letting their kids communicate in new ways with other real people, right? So psychologists talk about the audience effect, which is sort of what I'm experiencing right now, which is when you're in front of an audience, you try and be a slightly better version of yourself. I mean, I'm not this coherent at the breakfast table, right? You're getting Clive Thompson 2.0 here. So whenever you go before a real audience, suddenly you actually work harder. And so teachers I would go to these schools, and my rule actually was in the research, I would only go to public schools and generally only go to underfunded public schools. Because if something was working in one of those schools, it was going to work anywhere, basically. And they would, whether it was English teachers or social science teachers or people teaching geography or whatnot, and I would say, so what are you actually doing with technology that's sort of working? And they would all say, well, it has to do with actually letting kids do things in front of other real live people. Whether that was they'd set up a blog or a wiki or something, or they were doing a community project that other people were going to look at. The ability to sort of make connections and have them go, oh my God, this isn't just for my teacher, who is sort of an inauthentic audience, is what psychologists would call. Someone being paid to read what you write is an inauthentic audience. An authentic audience is one that gets bored and walks away if you stop interesting them. So all the kids would do this much more remarkable stuff when you just did something as simple as giving them a real connection to an audience online. And the science really backed this up. They would do these studies that show, if you take, and this is college students, but it worked. They'd write their papers, and they'd sort of write these half-baked papers. Then you say, all right, we're going to put these online for people to read, in Australia, and they go, oh, wait a minute. And they'd rewrite it like 40% longer with much better language and whatnot. And the same thing was happening down, and I talked to these people in New Zealand who were doing this with elementary school kids who were like English as second language learners, really difficult teaching stuff. Suddenly, relatives from Germany were reading what they were writing, and they were working way harder, and they're arguing with each other about, how to improve their writing. So across any discipline, the really simple trick seemed to be use whatever tools it is, free ones ideally, to give the kids an authentic audience. That's the one thing that technology was really doing.
And this sort of pervasive
any discipline, yeah, exactly. Whether it was music learning or whether it was history or whatever it is, when you let them go before real other people, it brings out their best.
So hopefully, by this point, we're trying to convince you that science is every day, science is everyone, science is all of us. Rachel has a fantastic quote from Rachel Carson from Silent Spring, and she says, "We live in a scientific age, yet we assume that knowledge of science is the prerogative of only a few small number of human beings isolated and priest-like in their laboratories. This is not true. The materials of science are the materials of life itself. Science is part of the reality of living. It is the what, it is the how, and it is the why of everything in our own experience." So I think whether we're talking about Skyping with colleagues and expanding our classroom, or if we're talking about Rachel's book is amazing, 52 biographies of female scientists maybe you've never heard of, and the achievements that she profiles, you realize things like the APGAR score. That's actually named for a female scientist named APGAR. There was a female scientist who invented arguably the first aquarium. She was also, correct me if I'm wrong, a fashion designer earlier in her life? Yeah. So you find out that these remarkable achievements permeate our everyday life, and these are everyday people, and we are sort of everyday immersed in technology and science. One thing, though, that came out in the panel last year was a talk about math phobia or science phobia. So it's very pervasive, and something that both Rachel and Clive talk a lot about is how sometimes that might keep people back. So going forward, if we're talking about inspiring future people, what would you say some impediments are sort of a math phobia or science phobia keeping people back in terms of how they use technology or science?
Yeah, what do you think? No. You tackle this one first.
It's sort of a new question I'm throwing at them.
I'm interested in what you have to say, Rachel.
Well, I would just say personally, there was some point in my education where I thought oh, well, mathematics isn't for me. Yeah. I'm not the right. I'm not. This this is not my thing, which is really funny because I recently went back to my junior high when I published the book, and I was talking to my math and science teacher, and they were like, "You were so great in math," and I was like, "No, I wasn't." And they were like, "Yes, yes, you were." And I just hit this block where I looked around and thought like, "Oh, this isn't my place. English is my place." But I also think we were talking a little bit earlier about poetry, and I was certainly more inclined towards English at a young age, and I think that this Sophie Kowalewski, who entered in the sham marriage, she said that it was a mistake of the uninformed to mistake mathematics and arithmetic. Arithmetic is a pile of dry and arid numbers. You subtract, multiply, etc. But mathematics is poetry. It's creativity. And I never reached that point in my education. And I think maybe if I had thought about it that way a little earlier, I may have been a little more invested.
Sorry, Clive, I'll give you a chance to think on your answer. I just want to build on that, Rachel. Do you mind talking a little bit about the women you profile and just sort of some of the qualities? They persevered through extraordinary challenges, many of them. Could you talk a little bit about the sort of tenacity and the qualities that they had all in common that sort of had them succeed in spite of all these challenges?
Sure. So we talked about creativity, certainly. There was a kind of grit, perseverance, an ability to know 100 different ways from 100 different people. No, you can't be an engineer. No, there's no way that you can work at this company. No, your ideas are not valid. And kind of perform career parkour and get through all of those things and be able to still achieve and kind of know that you were better than what other people thought of you. So that was something I certainly saw. And then there's this thing about spaces. Some of the women in the book, they worked out of a university attic because they weren't allowed an office. They worked in a janitor's closet. So there's the kind of Virginia Woolf thing of finding a space, of a room of one's own. But then there's also kind of creating the intellectual space. So maybe a lab environment wasn't quite the right venue for some person's knowledge and some person's work, and so they'd find another one. They would hold lunch meetings where they could discuss the sciences, and in some cases that was a better forum.
And I think the community of science. So one of the things Rachel does in her book is she only focuses on female scientists whose careers have finished. And one of the people she excludes, gasp, is Marie Curie. So one of the reasons you do so is for a very purposeful reason, to show that other community of scientists that were with Curie. Do you mind talking a little bit more about that? And we'll get back to you.
No, go ahead.
Yeah, so when we talk about women in science, we talk about Marie Curie. When I was researching the book, every single person I talked to, and I am not exaggerating about this at all, I'd say, "Oh, I'm writing a book about women in science," and they'd say, "Oh, great, Marie Curie." I got a deck of cards of famous scientists, and I fanned it out, and it's Marie Curie and no one else. I mean, she's amazing. She's an amazing lady. But if we think of her, if she's the only extraordinary female scientist that we know, that we talk about, can you imagine being a kid and thinking like, "Oh, I want to be a great scientist, but there's this one, and no one has come even close to that since she was alive." So I think there are many, like way more than 52 incredible women in science. And the more that we could talk about those stories, that we can say, "Oh yeah, the inner core, it was discovered by a woman. The inner core of the Earth discovered by a woman. Nuclear fission, there was a great woman who helped with that." Just kind of in every area of science, we just don't talk about it. So that was the goal of the book, so we can talk about more women.
So I think similarly to Clive, you talk a lot about community, and especially how technology is creating these new opportunities for community. What were some of the things you observed in the classrooms you went into that were really successful, concrete examples maybe the educators can use as takeaways?
Well, sure. So some of the, and I can rope this back into teaching, math and science in different things. I mean, one of the main things that came out was exactly what I talked about earlier before, which is the provision of an actual real audience. And that was, I can't overstate how catalytic that was over and over again. Whether that was there's a woman I went up to in Ontario, I visited her school. So she had I think middle school grades. and she was doing a segment on Hannah's Suitcase, which is a book about a young girl who was killed in the Holocaust. And so they decided that one of the things they were going to try and do is learn a lot about it and then host like an online Twitter conversation about the book. And so they had their hashtag, and they did a lot of preparatory work to have things that they would write about themselves and questions they would ask people. And so it was really interesting first because again they don't want to embarrass themselves in front of the world, so they actually were working really hard at thinking of things to say about it. But it also turned out to be a really interesting lesson in civics, right? Because when you're dealing with the rest of the world, you're now dealing with how to behave responsibly in front of other people. What if they behave badly, right? And so they had these fascinating conversations leading up to it about what happens if no one shows up? What happens if people start saying racist or hateful things? What if we get some Holocaust deniers? And so it started off as like a way to interrogate a book and wound up becoming this absolutely interesting experience. And when it went online, it was really wonderful. And they got all these these people to talk about it. So it was an example of a way to integrate audience into making history really come alive. The math and science stuff is really interesting too, because I would ask teachers, how are you, we're having this trouble with math. How do you teach math? How do you make it relevant? It isn't always easy, but it's in a lot of different hidden places, right? So one really fun example was this. One guy talked, I guess it was around grade 10, and he was trying to get kids interested in thinking about math and doing models and projections. And so there's one thing teenagers are starting to do, which is figure out how to afford a mobile phone. And they will have these Talmudic conversations about which plan is the best one to get, and because they have a tight amount of money and it's a tight constraint. And so he said, well, so he started, saying, well, let's build some kind of Excel spreadsheet models of if you use this much and whatnot. Anyway, this became these sprawling, fascinating economic models of what different behavior would be like and how much it would cost, and they all sort of figured out exactly what plans they should get. And this, so this is integrating all sorts of fascinating things from math to, how much communication do I really need to do in this mode? If we got a family plan. So there was all these, real world stuff getting roped in.
Sorry, an aside, Talmudic conversations about mobile plans should be like the tweet of this panel.
And the other short one I'll give is sort of based on, so Seymour Papert, who is one of the this pioneering thinker about education and math. And his interesting epiphany, he said that, why don't we learn math? And he said, well, it's the same reason that like kids in North America don't really learn French. They don't use it every day. They don't live in France land. If you go to France, you'll learn French quickly, right? So you got to go to math land. Now, what is math land? He said, well, actually, computers are kind of math land. They talk in math, So whatever you do in them, you want to talk in math. So he would do these things like he would make little Mad Libs things where you have to fit in, the noun and the verb here. And these kids would sort of play with it and just pump in different things, and you put a bunch of random. And eventually they started figuring out why we have nouns and verbs. Because if you put the nouns in the verb place, but the verbs in the noun place, the sentence doesn't make any sense. But by seeing this machine iterate these ridiculous sentences versus sensible ones, they would sort of go, oh, I get it. And I saw people doing this with Scratch, which is this very simple language. They would like sit down and go like, show the kids here, here's how to write a whole list of verbs, a whole list of nouns. Now we're going to make crazy sentences and mix them up and see what works and what doesn't work. So they were sort of using this very simple programming, stuff you can learn in 15 minutes. There's primers on this to really get them to think about language in a way that it's watching a machine automatically generate 200 gibberish sentences and then 200 coherent ones is really fun and catalytic for them thinking about grammar. So there's some. I saw a lot of examples like that.
That's really cool. So we've got lots of examples for technology. I think I'm definitely going to pose this to Clive, but Rachel, please jump in too. I think one of the problems sometimes we have with technology specifically is not necessarily that there aren't good options, but there are sometimes too many options. I know in the classroom there's so many tools. Clive talks very well in one of his chapters, The Digital School, about a successful use of Khan Academy, for example. But we have so many options available to us. So one of the things I would ask, definitely for Clive, but Rachel, please, as you were doing your research, what are sort of your recommended takeaways for educators, and what are some sort of specific examples that you've seen of good technology programs and maybe good programs to encourage future scientists?
Well, one thing I learned, and again, this came from visiting schools that didn't have a lot of resources, was that, and there's a caveat to this, but I'll give the principle first, which is, try not to spend any money on it, because there are so many snake oil salesmen out there. I mean, the whole ed tech world is like, it's almost like the defense budget, where like these companies just show up to kick at the piñata and see what money falls out, right? Because there's so many billions of dollars, and schools have all this money to spend, and the poor IT people, you know, they don't know what's going on, and they wind up buying some system that's incredibly complicated, and the information's all proprietary, and you never get your hands on it, and then it breaks 4 years later, and the company's out of business. I mean, I was led.
Doesn't sound familiar to me.
Yeah,
right?
I was led into the basement of schools where I was shown, like, you know, cords of stacked up broken electronic whiteboards, you know, covered in dust that cost, like, you know, $10,000 each. It was so the one rule I learned is don't spend a penny if you can do it for free, and you generally can. Like, so all the stuff I was seeing that was great was like just free wiki software, free blog software, Twitter, you know, things like that. Again, things like Scratch, which are, you know, free, made by MIT. I mean, the caveat there is that a lot of the stuff is free because you're handing over a lot of personal information about the kids to Google, to however, to Twitter. So you have to sort of figure out your policies for, you know, minimizing their exposure, and you have to think carefully about that. But generally, my rule is, you know, don't spend a dime if you don't have to, because a lot of the stuff I saw was being done by, you know, free or near free software, you know.
I think the other thing is often to find the right tool that works for you, maybe in your classroom. Again, we have so many options in the library. We have a lot of maker spaces. Once upon a time, we all had Wii's. So it was like, oh, let's get video games in the library. Not every library is going to be a perfect fit for a maker space or for a video game space. Like, it really has to be the right tool for your classroom and for your students. I'm going to turn over to you, Rachel. What are some female scientists, current female scientists, that you see doing really exciting things, and some of the successes that maybe are going to inspire future female scientists?
Great. So I would just say that, like, whatever list I come up with is going to be 4 people out of thousands and thousands and thousands. There's somebody doing an amazing thing in every area of science. But I recently saw a presentation from a Stanford computer scientist named Fei Li, and she has taught computers to read images. So you know, computers are really bad at reading images, and she's, through years of teaching computers how to do this, finally a computer is able to say there's a dog standing in front of an airplane. Wow. That is an incredibly complex task. So that is really great. I have a little list because I feel like I'm going to forget the names.
We all brought lists because we knew that we were, except Clive.
I was allowed to bring a list?
Yeah. Rachel and I brought lists.
Your work on memory is
transformative, yeah, exactly.
This list. You know, Sarah Seeger is the first to discover the atmosphere on a planet outside of our solar system. You know, we just had Yu Tujus won a Nobel Prize for her discoveries concerning malaria. Really, every aspect of science. There's Natalie Cobrell is exploring the world's most extreme environments in order to learn how we can live on Mars. Just really interesting research.
You know, actually, I'll jump in. One of the things that a lot of teachers told me that they were doing that was, one of the most used technologies that they found was great was Skype and GChat, because they would basically email someone and say, hey, can you talk to my class? And it's astonishing the amount of people, like scientists, that would just go, yeah, sure, I'll give you half an hour. And it was, and this was always just electric for the kids, basically. In fact, there's this guy in, I'm blanking his name. You might remember him. He's the famous Indian educational guy who did the hole-in-the-wall computer. Do you remember that? Anyway, so he was having, you know, he was working with these Indian schools that had, like, you know, 70-to-1 teacher-student ratios, and he basically set up 3 or 4 computers, and he got like 60 retired women who had experience in math and science in the UK to agree to just sort of be available at any point in time on Skype. Because they're all retired, they're sitting around. And they're like, yeah, sure. And so these kids would just, like, they would have this, like, 74-year-old pensioner on tap to talk to all day long about math and whatnot. And the kids started calling it the granny cloud. And they would just spend hours talking to these women were thrilled. They were like former statisticians and economists and all this stuff, and they were having the time of their lives talking with these kids. And again, this comes to audience and outside the it was a surprisingly powerful, simple tool. If you can get a single functioning webcam in your room, you can do it.
And we know that's easier said than done for every
Notice I said if.
But I think that's an important point. One of the things that comes out in both of their books, and I'm sure you see in your own classroom, is just the importance of role models, advocates, and also the one-on-one mentoring. Would you guys mind talking a little bit more about how you see that as being really vital for STEM going forward?
Yeah, I could tell about so one of the things, as girls are kind of growing up and thinking about what they're going into, I mean, my physics classroom had pictures of Einstein everywhere, but not even Marie Curie. So, as girls are thinking, oh, I may be interested in this, I may want to pursue it, it's important to know that there's a place at the lab bench for them. And so the more of these stories that we can share and show, like, yes, of course you can go into astrophysics, like, yes, of course you can be a computer scientist, that is so important.
There's even your story about Sally Ride that you include in the book.
Oh God, yeah, that's a great story.
When Sally Ride's father writes in.
Oh, right, yeah. So there was an advertisement for a kind of, I'm trying to remember what the advertisement was, but it was a boy, and he was dreaming about going into space, and Sally Ride had just gone into space, and so her father wrote in and said, I know firsthand that girls want to go into space too, and so you should include them in this advertisement.
Yeah. Well, and another woman who's mentioned in Rachel's book that I feel terrible that I didn't know about because she's local, she's New York, and she's hugely influential is Jane Wright, who's considered the mother of chemotherapy from New York Medical. And that was sort of shocking to find out that her story was exceptional. Rachel was saying that even her daughters were sort of unaware of her achievements until they attended her funeral. And at her funeral, people came up and were mentioning, your mother had all these achievements, and they were like, oh, wow. So I think what comes out in both of your books is just, it's so important to having that mentoring, those opportunities, using technology if you don't have the bandwidth within your own classroom or the expertise to use something like Skype to open up those opportunities for mentoring, for that one-on-one, for that support.
Yeah, absolutely.
Okay, going on. Okay, I'm just going to jump to the question that I kind of want to ask because I'm a librarian. What are you guys reading right now?
I'll let you go first.
Okay, so we were talking earlier. So I studied English, and because I'm a huge nerd, I looked at the history of English, and I realized, okay, so we've been doing this more or less. Let's start from, I'm not going to do early English, but like Middle English onwards. And I drew a line. I'm like, well, sort of, it's 80% poetry, so I guess I better read 80% poetry. So I spent my entire degree mostly reading poetry, and I wound up getting sort of addicted to it. So I mostly sit around reading poetry, which turns out to be sort of fun and useful because poets are so, they use language and they think in such different ways, and it sort of it clears my brain out after a day of reading, like, great but not always stylishly written scientific papers. It's kind of nice to sort of. So right now I'm rereading Absalom and Achitophel by John Dryden, which is a lovely, wonderful poem from my single favorite period of poetry, which is the 18th century Britain. And I'm reading a book, a really cool book called Seeing Like a Rover, which was written by a woman who, Jennifer Tezzi, who embedded herself with the team that is piloting the Curiosity rover around Mars, right? And it turns out that what the book is about, and it's incredibly interesting, is sort of like the Instagramming of Mars, because basically you're taking these pictures of Mars, but it's sort of raw data, and you have to figure out what you're looking at. And so it's really about applying different filters to the pictures until you bring out different aspects of what you're looking at. And the different different filters will show you different things. So it's learning how to see through the rover at Mars by applying these sort of Instagram-like filters. And it's just a wonderful look at how science really works.
That's really cool.
I just read Clive's book. It's great. So I'm going to go a different route of consuming media. So I've been, like probably everybody, been consuming a lot of podcasts. And I really love how maybe I wouldn't pick up a whole book on economics, but man, do I love Planet Money. And now I'm thinking like, oh, well, since I'm listening to Planet Money, I should maybe pick up some of these books. So as a route to kind of discover and also get outside of my comfort zone of what I usually read. Like I go to the, I get recommendations from the same kind of people. I end up going through the same channels, and podcasts have been a really great way for me to kind of broaden what I'm interested in. So like, if you want to know about startups, you can listen to the podcast Startup, or there's a great show about the internet called Reply All, and it's been a really, really fun discovery.
Stuff You Missed in History Class is one of my personal podcast favorites. But part of the reason I'm asking them that is, one of the things I think that comes out when we talk about science and technology is that we sort of self-edit. We sort of assume that we're not science or technology people, and so we might not actually pursue reading widely, and sometimes that even influences the students and maybe the materials that we give them. So one of the things that we've talked about a little bit, but maybe we can talk about a little bit more, is how do we create inclusive classrooms in which girls feel like they can go into science, students feel like they can be creative with technology. What are some of the steps forward that you see?
Well, I mean, I think it's what Rachel's talked about and what her book has done, which is role models. I mean, it's all, this is just hugely important, whether that's the posters, yeah, exactly. It's a great, and actually Rachel's doing
Can we announce that?
I don't know. Can we announce that?
Yeah.
Oh, yeah, okay. Rachel's doing a school middle grade version of it, basically. So it will be a book that is filled with role models like that. I think anything that brings that in is great, whether that's posters, quotes, books. I mean, this is not rocket science. We sort of know this. It's just
it seems self-evident.
It seems self-evident, yeah. But you have so many things to do already. One of the reasons there's this part of me that sort of hates sitting in front of teachers and telling me, here's what you should do. Because who on God's green earth has more people telling them what they should do with their day than teachers, right? It's like, do whatever you're doing and try and not be rendered crazy by all the various, interests telling you what to do. But that role models. There you go.
Yeah, role models. I think including some of the stories behind. We go through learning about all these different things, but we don't always get to pin them to who contributed. And so I think, including those stories may help people grasp onto it a little bit more. At least I think that would help personally. But I'm also a little prone to that since I write stories. But
I think what's really great also about both of the books is we talk so much about literacy across the disciplines. And one of the great things about these two books is it's science and technology and it's literacy. The other thing is simply that we're giving students more context about the people that they're studying. And I think it makes it easier for students to see themselves, to have that potential. I'm totally blanking on the female scientist's name, but she got her PhD at I think age 41. It was 100 years ago. Haven't given you enough information, but just to show students that they can have the tenacity and they can pursue things. I think also, Clive, the stories that you go into, he talks about supercomputers. You actually got to play against one of the supercomputers, correct?
Watson, yeah.
Watson.
Yeah.
Is sort of to see the stories behind these technology, behind these very famous scientists, that they are humans. They are human beings just like the kids in the classroom, that they had struggles, and that even something like Watson had to be fed all of this information.
Oh, God, yeah. I mean, the people who made it were driven mad by trying to do that.
Do you mind talking about Watson a little bit? That's a great
Sure. Dave Ferrucci, the scientist who had led that team, was a lot of fun to hang out with. He is such a driven individual. He's the only person I've met who was prescribed a mouth guard because he grinds his teeth during the day when he's awake. Oh, there we go. So it was really, it was crazy hanging out with those guys and watching them try and put that all together.
This is a supercomputer.
Supercomputer that plays Jeopardy. Yeah. It was the one that played Jeopardy and beat all the Jeopardy. Certainly beat me. I'm terrible at Jeopardy. But it was it beat Ken Jennings, who was the best Jeopardy player in the world. I mean, over and over again. I mean, Rachel and I were journalists, so we go for the story. But it turns out that every time, and I've learned this from trying to do journalism for years, that the only way to get people really interested in something that they don't know they're already interested in is to tell them the story about it. The nice thing about science, in a weird way, is that it's always a mystery story, right? I mean, I don't know what it's like with your writing, but I've found that almost sometimes I'm like rehearsing the story like for my friends before I write it, so I can I'm trying to figure out how can I make this more enticing. Yeah. And what I've realized over the years is that stories about science, the hard part, the easy part is saying what you know. Because you can sort of say, well, we now know this about the way cells divide or the way cancer works. The hard part is reconstructing the state of ignorance before we knew this, right? And that's it's like writing, like an Agatha Christie detective story. The person was discovered dead on the chapel floor. What happened, and then moving towards that. And that so one of the nice things about science is it's this constant fun whodunit, basically, and the more you can sort of present it that way, the more fun it tends to be.
To sort of lift the veil to and show students the process behind it, that so many of the scientists you profile, or even all of the technologically, all these innovators that you talk about, is that they tried and they tried and they tried and they tried and oftentimes failed and failed and failed and failed, and then suddenly they had breakthroughs. And just to know that it's okay to continue to persevere.
Well, and in a deeper way, I'm just going to jump in. Sorry, I'm rambling on here, but I think the biggest thing about science, and this is what is so extensible to everything from thinking about your cell phone plans to whatever, is that, and the way it's sort of mistaught, I guess, is that it's taught as a bunch of facts that you need to know, right? So, no, it's about how to figure out something that you don't know. And we do that all the time. We're trying to figure out, how do I cook this? How do I, what pitch is going to work best in baseball? What design, what color combination is going to work best?
Cell phone plans.
Cell phone plans, yeah, exactly. It's how do you basically constantly think of how something might work, test it? That didn't work. Come up with another idea, test that. And we do that all the time. We don't call it science, but that's what it is basically. I mean, that comes out over and over again in the stories, in your book. Basically, people are just calling the reason why the women discover what they discover is they just figure out another way to ask the question, another way to test it.
Clive has another great example in his book about video games. Kids who are really into video games, and he tells them, well, you're doing the scientific method, and they're like, what?
Yeah.
But in fact, they had taken, this was another Excel spreadsheet where they had actually compiled all the moves of their opponents and were able to scientifically prove he uses a fire spell, he uses a hammer, and actually break it down and figure out what the best.
Yeah. No. Kids with video games, I mean, basically, it's a mysterious system. How does this work? How do we beat this thing?
Yeah.
How do I get to the end of this? And so you start off with some idea of how it's going to work, and you do it, and you die. All right, that hypothesis doesn't work. So and you'll listen to kids talking about video games, and they sound like they're in a lab. They're like, well, I think if we were to do a fire spell mixed with a sort of wounding, no, it's not going to work. I tried that last week, so it's really, I mean, and Minecraft is just hilarious in that regard because it's a game that was created with absolutely no manual for how to make anything. So, you're just blundering around trying stuff, or you're going I need information. So let's go and find the wiki. Let's talk to our friends. It's all this knowledge construction that is exactly scientific and research-based. It's really interesting. I don't know if you've seen much of Minecraft with kids at all, but it's fun.
We actually tried to do it in the office, and all the students that we have that they totally kicked our butt. And they were like, no, you're doing it wrong. And it was kind of a great thing as an adult to sort of, it was like our own inverted flipped classroom because we had the students telling us how to actually use Minecraft correctly. But I think, sometimes, obviously it's easier said than done in the classroom, creating those spaces for creativity and experimentation. But obviously we're seeing that whenever possible, creating those opportunities is great. One of the things I just also wanted to call out is we are seeing a lot of representation and sort of role models even emerging in terms of online communities. We have a very popular hashtag, I am an engineer. Is anybody, show of hands, is everybody aware of that? I am an engineer is great. You guys should check that out on Twitter today. It's all pictures of female engineers who are sending in their photos saying, I am an engineer. And oddly enough, there's even been some pushback of people saying, oh, she doesn't look like she's a scientist. The whole point is everybody is a scientist, and that there's a whole range of people involved. There's also hashtag Black in STEM and also hashtag Women in STEM. So there's all these.
Black Girls Code.
Black Girls
really
Code,
fun.
of course.
Yeah.
And we have Girls Who Code too. So I think there's starting to be more programs and more communities that are emerging either online or actually in the classroom that people can connect to. But sort of going beyond that, I guess, what do you guys see as the future, some next steps, and what are you working on next? You've talked a little bit about, Rachel, do you want to start and just tell us a little bit more about the middle grade adaptation?
So we have a middle grade version of the book coming out next year, which is really great because it seems like what we've been hearing is that parents are reading, like censoring some of the stories and reading some.
Which ones are they censoring?
Well, I mean,
the sham marriage, no.
Sham marriage. Yeah. There's like putting cocaine in the eye. I mean, there are
that
some
was very
that
common though.
there are some that are just
Who
not.
hasn't done that?
Yeah.
Maybe not appropriate for your fifth grader. Yeah. And then some of physics, for instance, is perhaps a bit too high for a 10-year-old in some instances. So we're excited about that coming out next year.
That's awesome. Clive, do you want to talk about what you're working on next?
I'm doing magazine work, but in fact, actually, I probably shouldn't talk about it yet because you'll find about it when it gets printed. But the one thing I can talk about is that I'm going to be doing a new book for Penguin about the psychology and personality and worldview of computer programmers, basically. They're sort of running the world now, so what do they think? How do they work? What makes them tick? What do they understand about the world that we don't get? What do they radically misunderstand about the world? So that's gonna be a lot of fun. I'm gonna spend the next little while profiling and interviewing people from all sorts of different countries and about programming.
And when is that supposed to come out?
I don't think they've announced a date yet. I'm literally just we're about to hit the firing gun on it.
It's exciting news. I guess just the last thing for you both. Rachel's book does have an educator guide available. Clive, yours unfortunately doesn't, but what are some applications that you could see for your book in the classroom?
I think it would be, frankly, I think it is, if you wanted to, I know you're busy, so I'm going to tell you the quick way to read the book. Read the chapter on public thinking, and then read the chapter on education. You're good, basically. That's probably an hour or two, and it'll give you some concrete examples of stuff that I found that was sort of useful in the classroom, and the public thinking stuff is really related to it. I try to be incredibly exhaustive in the bibliography, so there's some stuff in there that can be a lot of fun to hunt down as resources for the teachers. The other thing I would encourage everyone to think about is you don't really have to do anything that doesn't seem like it's going to fit into your, it's useful to experiment, but don't kill yourself trying to do something that is radically outside what you're doing. Just try and find something that, make the experiments simple, see if they work. If they don't work, abandon it. Don't put a lot of sunk. All the teachers I found that found something that worked, they did a little experiment for an afternoon, didn't work. They tried something and then they hit upon something that really blew up, for them. Whether it was some interesting use of Pinterest, to gather photos, so the kids were thinking visually about a new topic. And it was never the same, right? It was different for every teacher because every teacher, so it's a little hard to say, what I think you should do. I just encourage people to do lightweight experiments that don't require an enormous amount of time. And there are some good websites out there. Teachers are talking about public thinking. Teachers are fantastic at sharing the things so whether that's, DML Central has a whole bunch of resources. There's a lot of great teacher blogs you can look into.
Do you have anything to add?
Yeah, I think that the profiles in the book are 1,000 words, and so it's you can kind of skim through and see what you're interested in. And again, there's a great notes section, so many of the people profiled have a wonderful book-length version of their life that you can then give to students.
I think one of the best things too, Rachel has 52 biographies, so she makes a suggestion in the introduction. If you read one biography every week over the course of a year, you will meet, new female scientists that you didn't know about. So it's a fantastic thing. You could do it as a read aloud, even for a high school group. I think that's great. We don't talk about read alouds that much, but these are a perfect length. You could easily do it. With Clive's book too, it's published essentially as short stories almost. So
there's a lot of short chunks, and so I think some of the, for teenagers, some of the stuff about gaming would be very interesting. And there's a whole bunch of stuff in there about that.
Or even for, if you have a book club for educators at your school, this would be a good place. You could assign a chapter and you could talk about it, like the digital school chapter. This would be a fantastic starting place. I think we're at time. Okay, thank you guys so much. Thank you for